Hey guys! Today we're going to introduce combined and jointly variation. This tutorial is made by Sofia Castellanos and Gabriela Pais. Jointly variation is when one quantity varies directly as two or more independent variables. Keep in mind that it only varies directly and not inversely. Here are three examples of the possible equations for joint variation problems where y is the dependent variable, k is the constant, and x and z are the two independent variables. The first one is y varies jointly to x and z. The second one is y varies jointly to the square of x and the cube of z. And the last one is y varies jointly to x and the fourth power of z. These are not the only three examples, but these are kind of the fundamental ones. Here's a word problem, and it says the volume of a solid with a circular base varies jointly at the height h of the solid and the square of the radius r of the base. If the volume of the solid is 75.4 centimeters squared, the radius is 2 centimeters and the height is 6 centimeters. Find k. So in order to find k, you need to write the equation, which in this case would be v equals khr squared. And now what you do is replace the variables, so your new equation would look like 75.4 equals k times 6 times 4. And after you multiply 6 times 4, which is 24, the next step of your equation would look like 75.4 equals k times 24. And then you divide 75.4 by 24 and you get that k equals to 3.1416 or pi. Here is another example where they tell you the equation is y equals kxz, and now they're telling you the value of each variable. Y is 45, x is 5, and z equals 3. So just as in the previous example, you have to replace the variable. So your equation would look like 45 equals k times 5 times 3. And now you multiply 5 times 3 and you get 15. So the next step of your equation would look like 45 equals k times 15. And after you divide 45 by 15, you get that k is equal to 3. So imagine you get the equation y equals 3.1416 hr squared. In this case, h and r are both independent variables. So keep in mind you cannot graph both independent variables in the same coordinate grid. So what you do is sort of separate the equation into two parts. The first part, which you can see in the graph at the left, is y equals 3.1416 h, only using h, that is the independent variable, only using one independent variable, which will give you a line. And in the second graph, which you can see on the right, your equation would be y equals 3.1416 r squared, which will give you a parabola. See that in one graph we used one independent variable, and in the other we used the other. And you just leave it like that because you cannot graph both on the same coordinates.